Hi everyone.
Hi Nathan.
I'm Nathan, also known as Taneb. And I'm going to be talking today about, the title of the talk is A Tour of Esoteric Programming Languages. And can anyone tell me, what is a programming language?
It's something Turing complete that's probably text-based, or, well, no, not text-based, but is on a computer and you interact with it digitally.
And it doesn't have to be Turing complete.
Yes, I suppose DSLs.
Yeah, more or less. And what are programming languages normally designed to be?
Useful.
Useful. Yes. Now, what happens if a programming language is not designed to be useful?
It's an esoteric language.
Yes. The first such language that I'm going to be talking about is HQ9+. Now, as every programming language has a few example programs shown in it. Hello World is a common one. 99 bottles of beer is another common one. And then some people write quines. And someone realised this a few years ago and thought, you know what, I'm going to make a minimum such language such that they can do all of those things. And it has the commands H, Q, 9, and plus. H prints hello world. 9 prints the full lyrics to 99 bottles of beer, which I'm not going to write on the whiteboard. Q prints the entire program source to the output, so as a quine, and plus increments the accumulator. You can't do anything else with the accumulator, you can just increment it. As you can see, it's a very useful language for it can do all these common programs. Okay, that's all there's really to say about HQ9+. The next language I'm going to talk about is Deadfish. And Deadfish was designed to be so hard to program in it. Programming it just like eating raw fish heads. It has, again, 4 commands. It's increment the accumulator, decrement the accumulator, I'm probably getting these wrong, I can't quite remember, square the accumulator, and output the accumulator. And I think that uses the ASCII value of or Unicode value of the accumulator rather than putting it as a number. So, and when the accumulator gets to 256, it wraps around to 0. Except the reference implementation had a bug such that when you're squaring it rather than incrementing it, you can go past 256, so it's effectively unbounded. And that's Deadfish.
Has anyone actually written anything in it successfully?
Yes, you can print all manner of text outputting programs in it. For nothing more than that.
Fair enough.
And, yep. Now, all the programming languages I mentioned after this, you could are probably more useful than these two. Now, now I'm going to wind down the projector thing while I'm waiting. Okay, the first, I'm going to go back in time now to 1972, and a couple of people decided to make a language that was completely different from any other language that existed at the time that they knew about, which is mainly things like Fortran, COBOL, Lisp, maybe C, few of that era. And they ended up with a language called Compiler Language with No Pronounceable Acronym, or for short, INTERCAL, for obvious reasons. INTERCAL had things, didn't have arrays, I don't think, you had to be polite to the compiler. a third to a fifth of your commands had to be preceded by the keyword please. I do not. I am afraid I do not know INTERCAL very well at all, so I'm not going to talk for too long about it. Right. Have any of you heard of the not quite so esoteric language Forth?
Yes.
Yes, that's not esoteric.
I know. I'm saying I said not quite so esoteric. Well, in 1993, I think, someone decided to make a Forth-like language that had as small a compiler as he can manage. He managed to create the language false, named after his favourite truth value, which had a compiler that for the Amiga OS, I think. There was only 1,024 bytes. And that's, I don't know false that much either, so I'm not going to talk about it. The next language, also invented in 1993, someone saw this compiler and thought, with a smaller language, I could do a lot better than that. So I think it was Urban Muller created a language called Brainfuck that operated not in a stack, not in an array, but on a tape, which you could move backwards and forwards arbitrarily, one cell at a time. You could increment the tape and decrement the tape, and have loops that kept executing the content within the loop whenever the cell value of the cell pointed at the end of the loop was 0. No, until it was 0. So while not 0. So, and Brainfuck is probably one of the most famous esoteric programming languages, and it's pretty useful. It is Turing complete. I think someone wrote a text adventure game in it, which was an achievement. I haven't played it, and yeah, he managed to write the compiler for that in I think 257 bytes.
It's kind of terrifying.
Yes, it's a small language. The next language I'm going to talk about, where's this gone, is Underload. Underload is Forth-like, as in it operates on a stack. It's got, I think that's 8 commands plus the bracket, including the bracket syntax. Brackets push the contents of the brackets to the stack, and then tilde, I've brought up the specs so I can remember because this is a vaguely interesting one, swap the 2 top elements of the stack, colon duplicates the top element of the stack, exclamation mark discards the top element of the stack, asterisk concatenates the top element of the stack, switches them together, A wraps the top element of the stack in a pair of parentheses. S outputs the top element of the stack, thus popping it. And caret is the interesting one. When the caret command is called, it takes the top element of the stack and executes it as though it was an underload program. Now, this is pretty odd. But in these few instructions, it's actually Turing complete, even though there's no control structure here. The only control structure you can do is by pushing code to the stack, duplicating it, then executing it. That's a Hello World program, and this program here prints the Fibonacci sequence in unary, because there's no number literals or anything in this. So just does apply, I think, concatenating asterisks together. And that's an infinite loop, as it says, and that's a quine. And for everyone, I'm sorry, I'm just copying this. I've literally got the website open. And there's an online interpreter, so I can show you in more detail how the execute thing works. If
Program live.
say hello
You just say my talk.
S, right, single step.
All one big
Right.
down.
That's pushed hello S to the stack. Okay? And then if I do caret, it copies that back to the program and then executes it. Which is surprisingly useful. And now, another thing interesting about Underload is, well, you can compile, you can translate SKI calculus, which in turn you can compile lambda calculus too. So it is provable Turing complete that way. But also, some people with way too much time on their hands prove that, I think you can prove that it's Turing complete if you remove almost everything from the language other than parentheses and caret, and I think one other, but I can't remember which. Maybe tilde. Which took a lot of effort and involves Minsky two-register machines. So congratulations to them. The next language I'm going to, going back to 1990, wrong tab. Going back to 1993, someone completely disconnected with the whole false brainfuck thing, I think, decided to make another language that operated on a stack, but he decided to have the thing. Most programming languages, the code is one-dimensional. You do command, then command, then command in a linear way. This programming language, but all the commands are on a grid, and you can change which direction you're pointing in. And then in 1998, he revised the language to make it more powerful, because the 1990, oh, it's Befudge, I didn't say the name. The 1993 version is called Befudge 93, and then the 1998 version is Befudge 98. And it's a pretty rich language for an esoteric programming language. It's got loads of commands. It's push numbers and go west and turn.
Go west.
How many languages do you know that have a go west command?
Well, that one.
Exactly. And what's really amazing, to demonstrate how usable, oddly, this language is, someone, again with too much time on their hands, sorry if you're watching this at home, wrote an IRC bot that has in this language.
What?
This is some of the source. That connects to IRC, and if you mention its nick, which is Fungot, it's on Freenode, it works via private message, and it's also in Esoteric. It generates a sentence via Markov chains on a choice of corpuses, corpora. And it's pretty good.
It is. I almost wonder if you code it just so it's also images.
How do you do syscalls in it?
Pardon?
How do you do syscalls and things in it? I mean, I'm assuming it has to have a way to...
Yeah, I think it does. It's got a... the 1998 version has a load semantics command, which I think sort of loads an arbitrary plugin into it, and there's a list of standard plugins. and you can do syscalls
Yeah.
via one of them. Okay, and you mentioned how it was like making images. The next language I'm going to talk about, invented quite a few years later by an Australian called David Morgan Marr. Befudge was invented by Canadian Chris Pressey, called Piet, after the abstract artist Piet Mondrian. And in the language Piet, programs are images, and it works by looking at it's the hue and brightness of each block of single colour, and then the relative hue and brightness of the next one it moves to. It's got a pointer, and it's the difference between those that chooses what command it executes. And this is it's a prime tester. You input a number and it tests whether it is prime.
How do you input a number?
With difficulty.
It's it does have I/O commands. They're done by the difference in hue and brightness of the colours. Piet's actually one of my favourite languages, I'll say. It was also one of the first I learnt. But how am I doing for time? I've got plenty of time. Well, as much time as I need because I'm running out of talk. Piet, as is actually quite common in esoteric programming languages, operates on a stack. Most of them do, I'll be honest. Apart from the ones that operate on a tape.
Or the ones that operate on a picture.
No, this operates on a stack.
No, but the fun.
Befudge has a stack,
Alright, but also.
and it self-modifies, which is a grid of text characters. So, going back, I forgot to mention something with Befudge. I'm not very organised, am I? Back to here. One of the difficulties with Befudge is that because you can go into any command in any direction, and sometimes you'll be interpreting it as a string, sometimes you'll be interpreting it as a command, and also because you can modify the program during execution via the program, you can't just do it arbitrarily at the keyboard. It is almost impossible to compile. I do not know of any compilers that don't cheat for it. It's mostly interpreted. One compiler that does cheat for it takes every possible direction of commands. Like, say, that's a go west and that's a go south. It's skipped. So it goes along there to down there. That's also skipped. Ignore that. It takes
one side further across.
Yeah. It takes every possible series of commands that's in a straight line, compiles those separately with links to each other, and whenever the program is self-modified, it completely recompiles, or possibly slightly more cleverly than that, but it recompiles the program whenever it's self-modified.
So the compiled program contains its own compiler?
Yes. If you can think of a better way to do it.
I can't.
Befudge is almost always interpreted. And the last language I'm going to talk about is somewhat different to these, and for that I'm going to scroll this up again. Where is that? Okay. It's called slashes. And how many of you have used use the Linux utility sed.
Yeah.
Okay, for those of you who haven't, one of the most common uses for sed is to look over standard in, match over a pattern, and replace that with a new text. So you execute it like something like sed s/sage text. Something like T, and that's not at all. Replacement. Perfect. And so, what slashes this language, which I presume is pronounced slashes? Its title is not the most pronounceable. How it works is the source code is a series of /search /replace that operates on itself repeatedly.
Wow.
So probably get so a/ab a/b/ a/c/. The first thing it would see this, and then replace all the A's after that with B's. So that becomes, I'm probably getting this all wrong, becomes BC. Then if I thought about this in my head, then it can't do that again, so it looks at the next pair, then replaces all the B's after that with C's. And then so on. And you can put more slashes in using backslashes and slash, like escape character, like is common to many languages. And I believe this is actually Turing complete. But it took a very long time to prove Turing complete. I think it was eventually proven Turing complete by someone writing an interpreter for a tag system in it, which it took a while. I'm very glad it wasn't me doing it.
It's an interesting one, just as in you can see quite easily how you could implement like adding 1 to a number until you get to 9, and then you have ones and zeros in 10, so it will be replaced.
You could always do.
Does it support like proper regular expressions?
No, just raw search and replace.
Just literal strings.
Yeah. So,
Because that would just be too frightening.
Well,
I
especially if
think-
they were showing complete
I
regular
think there is
expressions.
a extension to it that supports regular expressions, but this one's cooler. So, if you want to say, what you were saying, I don't know, you could do some like 1 0 goes to 1 1.
And
but that,
I suppose what you'd actually have to do would be to go down, because if you were replacing 15 with 16 and then 14 with 15 and so on.
1920 or something.
Yeah, and you would have pairs of numbers going up, slowly going down within the range. But
I don't know.
it would be horrendously complicated.
Oh, that's something for you to think about.
This is actually quite an interesting one to me.
And that's all the preparation I've done. I've got a list of other interesting languages that I'm not going to talk about, except in vagueness. I'm erasing that, don't need to. There's Glass, which is stack-based, heavily object-oriented, and uses postfix notation. White space, where this is a white space program. It's all the commands are space, the space symbol, the tab symbol, and new line, and various combinations thereof.
It's like invisible ink for programs.
Yeah, I believe the main goal of Whitespace was to save on ink, and to be a great benefit to spies because you just print out your program and no one would suspect there's a program on a blank piece of paper that you can just type it back in.
But there isn't a program with a blank piece.
Well, yes, it is.
It's not even real.
Another fun language is Shakespeare. Well, all the programs look like Shakespeare plays. And there are other of that sort of thing where Chef, where they all look like recipes, and probably others that I'm forgetting. There are a few like that. There's Whenever, which isn't too popular, but I like it, where the program is a to-do, like, you know how old basic programs, it was written like a to-do list with numbers?
Yeah.
Well, in Whenever, it's executed like a to-do list in whatever order you feel like.
What?
It takes a random command and executes it.
Oh.
I believe that is A, it's possible to write entirely deterministic programs in it if you're clever enough and bored enough. And B, I think it's Turing complete. Although don't quote me on that. Another language that's interesting is Eodom drone. I don't know quite how to write that name. I'm probably spelling it wrong as well. Where the program is a collection of arbitrary, unlabeled, unweighted graphs. And the way it works is it takes graphs in pairs and searches for subgraphs of the current state graph, which are isomorphic to the first of the pair of graphs of the program. There is a default state graph. And then if it finds a subgraph that's isomorphic to that graph, it replaces it with the replacement graph. I think it's NP hard to implement, but Turing complete. And the last one I'm going to mention. Did I prepare the? No, I didn't. I'm going to go quick googling. This one has a interesting prog. I do not understand this language at all. Very, very, very few people do. This is a 99 bottles of beer program.
Let's see. Obviously.
I believe the programming language, A, its internal state is in ternary rather than binary, and B, it encrypts itself at every step. The first Hello World program was someone wrote a Lisp program that did a beam search of all possible malbolge programs, and then decided one that printed Hello World, all lowercase except for the final D, was close enough. I think this is, I don't know. Yeah, it was a Japanese researcher, possibly a team of Japanese researchers, who finally figured out how to write malbolge programs. And came up with this. I'm just going to say, this does not contain in any form the lyrics. It computes the lyrics rather than contains it. A program that contains the lyrics will be thousands of times longer. Even though this is already about 100 times longer than the lyrics to 99 bottles of beer.
Wow.
And yes, and that is the end of my talk. Any questions?
So when are you going to do a live coding demonstration in Marburg?
Ha! If you want further information, I would check out the esolands.org wiki and also the IRC channel #Esoteric at irc.freenode.net. Thank you. Question?
I was just wondering, it would be a fun idea to have a competition where you were given a program and you had to work out how the esoteric programming language that it was of, what it actually did underneath, what the commands did.
It'd be interesting for a quiz.
Less a quiz, more a...
It was more a remark than a
Yes.
question, really.
Yeah, could be a good idea. I would talk about that on the IRC channel. IRC channel, not there. Any further questions?
How do they kind of create the languages?
By treating programming language design as an art form.
That's definitely an answer.
Yeah. Also by having a completely random idea and pushing it to the max.
Yeah, fair.
Or by combining a few concepts that should not ever be combined.
It's the mad science of programming.
It's the mad science mixed with cookery side of programming.
The mad cookery of programming.
Yes. Put in some eggs and some paprika
That could work.
and some icing sugar. Have the vanilla as well, all of it. And it's the mad cookery of programming language design. And
Time for the next talk.
don't bush your luck.
Possibly the title of this talk.
The talk has rewritten itself as it goes.
Yes. Yes. And any other questions?
Turing Complete has lost all reading to
Yes.
I think that's a question.
That's not a question. Right.
And that will be the end of my talk then.
Thanks.